Hello and welcome. In this session, you're going to learn how to set up certificate-based authentication in Azure AD. We're going to go fairly deep in some areas. You'll understand how CBA actually works and why it is phishing resistant. You'll learn how to create appropriate certificates, where to store those certificates, and how to configure Azure AD to validate the certificates. Lots of demos along the way. Subscribe and keep learning, and join me in the cloud. Okay, let's start by thinking about how a user authenticates to an application. Our user goes off to the application, and the first thing the application does is checks if the user's already authenticated. And if they're already authenticated, they will probably pass a cookie as proof of that authentication. But if they haven't been authenticated, the app is going to redirect the user up to Azure AD. And they'll go to an endpoint, and that endpoint happens to be login.microsoftonline.com. Okay, so we go to the login endpoint, and we end up at the login endpoint. And that's where we would authenticate, supplying a username, a password, etc. But as soon as we want to do certificate-based authentication, we make that choice. We are redirected up to another endpoint. And this endpoint here is cert-auth. .login.microsoftonline.com. And what the cert-auth endpoint wants is for a TLS tunnel to be established with Client-auth. Now, all of these connections are using TLS, so they're using HTTPS. But this one wants to use client authentication. And for client authentication to happen for a TLS tunnel, we need a certificate. So the user will have a cert of some kind. And the user will also have a private key which never ever leaves their possession. As part of establishment of this tunnel, the certificate, along with the user's public key, will be passed to Azure AD. And then there will be some crypto magic happening, and there will be a signature of a digest of some of the information that's being passed. And that is signed with the user's private key. So the signature is actually generated on this digest and signed with the user's private key. Remember, the user's private key never ever leaves the user's possession. Now, that's it. We've established this secure tunnel, and the user has proved who they are using a certificate. It's a bit more complicated than that because we need to map that certificate to a user account in Azure AD. And I will come to that. Now, if we think about this, this actually has an immediate benefit. If we look at the perspective of a man in the middle or a person in the middle attack, our user is lured, it's a phishing attack of some kind, is lured to connect to the hacker's site. So there's our evil looking hacker in there. And we've connected to the hacker's site, and that will establish a TLS tunnel. And the user will think they're connecting to Azure AD. Now, what the hacker will be doing is it will be proxying the user's connection through to Azure AD, and it will establish a TLS tunnel. Now, if we were going to the normal login endpoint, everything could just work. And because the user's been lured to the hacker's site, the hacker can get all the information it wants because it's broken into the TLS tunnel. But if we're going to the cert-auth endpoint, what it is TLS plus Client-auth. And that is where it's going to fail, because to use client auth, what we're going to have to do is pass that certificate and a signature that has been created using the user's private key. Now, remember, that private key is locked in the user's possession. So there's no way that we can actually establish a TLS tunnel with client authentication. So it makes certificate-based authentication phishing resistant. What I'd like to do is do a demo using Fiddler. I'm going to start Fiddler, and Fiddler is going to act as a man in the middle and capture the traffic. So I'm just going to do a Control X in there, and now let's go to OIDC v1, and I'm going to sign in with OpenID Connect, and I'm going to go in as my user v-john. Sign in with a password, and everything's successful. We can see that we've gone in using a password. Okay, let's look at the Fiddler trace, and I'll just stop the capturing by clicking in the bottom left hand corner. We can see that we started off by going in here to OIDC v1, and that we can successfully see there. And the next thing is we end up at login.microsoftonline.com, and finally we end up back at OIDC v1. And during that time up at login.microsoftonline.com, we were actually authenticated using the password. Now, I will go through this trace in detail in a future video, but not for now. So let's just go back here, do a Control X, turn on the capturing by clicking the bottom left hand corner, and let's go off again to OIDC v1, and I'm going to sign in once again as my user v-john, and I'm going to choose another way to sign in. Now let's just go back to the Fiddler window and let's clear that out. Right, now I'm going to click on use a certificate, and it fails with an error message. So certificate validation's failed. Why? Because we've got a man in the middle. If we have a look at the Fiddler trace, what we can actually see is we've ended up going to certauth.logon, or certauth.login rather, and if I just highlight that there, and it's actually tried to establish a client authenticated TLS tunnel. It's failed, and so we've come back here, and the response that's going back to the browser is that error message. And if I just look in there, I can open that up in a little bit more detail, and if I decode the response, this lot here, which includes a lot of JavaScript, is actually what is being displayed in the browser. If you don't believe me, very simple. I can do a Control A on there, copy it. So I've copied it. And now what I'm going to do is fire up Notepad. I'm going to drop that into Notepad. I'm then going to save that file. So I'll do a save as, and I'm going to save it as an HTML file, and what should we call it? We'll call it the reply. This is the reply that came out, .html, and we'll save it onto the desktop. Okay, let's go to the desktop and let's have a look. There it is, reply, and let's double click it, and we can see that that is the error message that has actually come back from Azure AD. So our next question now is where to store these certificates. Well, we've got our cert, and we've got to go with it this private key. So our private key, which remember must never ever leave the client. One place these certificates can be stored in and looked at is through the Windows certificate store. So we could put it into the Windows certificate store, and that would be our personal certificate store. The other thing we can do is we can put it on a smart card. And Who can access the Windows Store? Well, it's the signed in user. So those certificates are just for that signed in user. Who can actually access a smart card? Well, it's the possessor of the smart card plus the person who has knowledge of the PIN of the smart card, or maybe we got a biometric to go with the smart card. Now, I could use a traditional smart card, or I could use a YubiKey. YubiKeys are actually recognized as Microsoft USB smart cards or NIST PIV cards. And they can be recognized just using the standard Windows drivers. That will only give read capability. If you want to write a certificate onto that card, what you'll need is the YubiKey Smart Card Mini driver to do that. That's if you want it to be automatically enrolled onto the key. If you want to actually add a certificate to a key, you can use the Key Manager utility that Yubico have. So 2 good solutions. One probably better than the other, but I'll leave it to your choice. Now, the next problem is, where do we get the certificate from? And to that, we need to create a PKI, a public key infrastructure. And these infrastructures can get actually really complicated. You could have a root CA, all right? And then you could have intermediate CAs. And the idea of an intermediate CA is that we can have different policies applied throughout our PKI. So we then have, below that, we can have issuing. So we have an issuing CA, and this issuing CA actually issues the certificates to our clients. As I say, gets very complicated. We could spend hours on this. It's X509 certificates. Have a look at creating a PKI. I've got a very simple PKI. I have a root CA, and that's it. So I just simply have a root CA to manage the generation and issuing. So I'm going to issue my client certs directly from the root CA. Now, one word of warning. If someone compromises your PKI and you're using certificates for authentication, then all of your authentication is compromised. So it's really important that your PKI is properly secured. If you're going to get into intermediate issuers and so on, I would really get someone who's got really good design experience to create it for you. So I say an absolutely big warning around this. Now, what else do we need? After a certificate's been issued, it can be revoked. And this is the CRL, the certificate revocation list. And we need to make that available. It needs to be made available to Azure AD, and therefore it needs to be available on a public HTTP connection. So we're going to have a server of some kind where we're going to put our CRL and maybe a Delta CRL as well. And that is going to be available via a public HTTP connection. Right? So there's quite a lot involved in actually designing all of this. But I've made mine as simple as possible. Okay, what I'd like to do is go and look at how we create an appropriate certificate to issue to our client. I'm working on the CA, so my certificate authority, and I can see I've got my certificate template. So what I want to do is go and create a new template to issue. And I'm going to come down to the smart card login, and I'm going to actually go duplicate template. Now, in terms of compatibility, we need to be up to Server 2016 on the certificate authority, and we need to be on Windows 10 Server 2016 and above in terms of the certificate recipient. That's who's going to receive the certificate. Next thing, if we go on general, we need to give it a name. So why don't we call this a smart key? Yeah, I think that's quite a nice name. We'll call it a smart key in here. And I'm going to go and move on to the request handler. It's got signature and encryption. I'm going to turn it to signature and smart card login. So yes to that. In terms of cryptography, I need to choose to put the information, the key storage provider, I need to switch that over, and I'm going to use the Microsoft Smart Card key storage provider. So that's in there. Key attestations I don't have to worry about. I don't have to worry about suspended templates. Extensions I will come back to shortly. Security, I want my users to be able to issue their own certificates for smart cards. So I'm going to allow enroll in there. And then when it comes to subject name, where's that going to come from? I'm going to build this from the Active Directory information. I'm going to change that later, but for now, we'll build it from Active Directory information, and we're going to build it for a user who is actually a hybrid user who has an on-premises AD account. Server, I don't need to make any changes, and issuance requirements, again, no changes required. So now we've got is our smart key. So we'll come up here and go to certificate templates and go new template and choose the template that we've just created, and we call it smart key. So there it is. Now I will be able to issue a certificate to a key. So we'll go over to the Windows 10 box again, and let's just close this browser session. And I'm going to go into my certificate store. And inside the certificate store, you will see a whole bunch of do not trust fiddler root certificates. I'm actually going to just delete those lot out so they don't cause any confusion. But that's how Fiddler is doing the man in the middle attack. Right? It's spoofing a certificate. So I've just got rid of those. All right. I also want to start up the Yubico key manager. So we go to key manager, and we'll have a look at the key that we've currently got plugged in. So it's saying insert your Yubico key, but it's detected it. I've got a Yubico key 4. And if I have a look at the interfaces, you'll see it's OTP, it's FIDO, it's CCID, smart card interface in there. If I go to my applications, I don't actually support FIDO 2 here. Okay, if I had a Yubico 5 key, I could support FIDO 2 as well. So one-time passcode and also PIV, which is a certificate. If we have a look on here, I can look at the certificates I've already got on there. I've got one for John. And what I'm going to do is I'm actually going to come back here and clear out absolutely everything. So I'm going to reset this. And then what I need to do is configure a PIN. And there is a default PIN. I can also use a PIN unlock key. All right. But I'm going to just use a PIN. The default is 1, 2, 3, 4, 5, 6. I'm just going to put in something that I will always remember. And change PIN. So now I have a completely empty key. Right, let's go and get a certificate. So I'm in my certificate store. I'm going to go all tasks, request new certificate. And next on there, it's using the Active Directory enrollment policy. So what we should find is we've got Smart Key available to us. And there it is. And I'm going to select that and enroll. And it's asking me for my PIN. And it's now writing it to the key. So it'll take a little while to write to the key. Now, you need to actually have the correct driver in to be able to write to the key. Right? Remember that Microsoft inbuilt drivers will recognize the reader, but to actually write, we need the correct driver in there, which is the Yubico Smart Card Mini driver. Okay, so we're all done. And now we're ready to test it. Click Finish on there and just minimize it for now. So we're going to go back to our application, but before we do, I'm going to close Fiddler. Otherwise, we will be prevented from logging in. So close the Fiddler, and now I'm going to go to my OIDC v1 application. Again, signing in with OpenID Connect. I'm going to go in as my hybrid user, John at 1.ad.xtshub.com. So we'll select him, and we could go in with password, but we're going to go in user smart card, and it's immediately detected that there's a certificate available. So I'm going to choose that certificate and click OK. And it's asking me for the PIN, so it can access the private key. Authentication method reference claim is showing RSA, so it's used cryptography to sign us in. Now, just before we leave this, I want to show you one other thing that can be very useful. We'll just switch back to our certificate authority and again have a look at the templates. And I've got one I created earlier, which is called CBA user set name. So I'm going to select that, and if we look at the properties and we look at the subject name used to be built from the Active Directory information. And here I've switched it over to supply in the request. So I can supply a subject name, and I can also supply the name that is going to map to our user principal or our user in Azure AD. And this is potentially very dangerous, because it means if an ordinary user was allowed to do this, they could create a certificate to represent anyone inside our AD. So this is very much a thing for administrators, but I wanted to show you this because it can be very useful when you're testing in your dev environment. Also, the cryptography I'm actually storing in a slightly different location. So I'm actually going to allow this certificate to be added in to my certificate store. So let's go back to our client machine and experience this. So I'm going to close the application, and I'm going to go back into my certificate store, and I'm going to go all tasks, request new certificate. And I'm going to come in here. Again, it's coming from an Active Directory enrollment policy. I'm using this one here, CBA user set name. And I can put in a name. In fact, the subject name isn't really important. I'm going to use common name, and I'm going to do in here v-tina, and I'm going to put in here first factor. And there is a reason for that, and I will come back to that reason. I then need to set in her user principal name, and that's what's going to map to the user principal name in the Azure AD. So that will map this certificate to Tina in the Azure AD. So we need to make sure we add both of those, okay, and just check they look correct, which they do. We're going to OK that, and we're going to enroll. And now what we should do is find a new certificate for Tina inside our certificate store. And if we look down here and we look at the details, and we come down to the subject alternate name, inside there is the principal name. Okay, let's just experience it as Tina. So we're going to go to our application, going to sign in with OpenID Connect. We're going to choose Tina, and it's actually showing, remember this certificate store is unlocked by the user that's currently logged in. Well, the Tina's actually in the certificate store. John's certificate details in terms of the private key is sitting on the smart card. So I will need to put the PIN in to get access to that. But with this one, I can just select it, and we've signed Tina in. And again, the AMR claim is RSA. Our next job is to tell Azure AD how it can trust our certificates. And if we're issuing a certificate from a PKI infrastructure, which is quite complex, let's say we're issuing it from our issuer down at the bottom left-hand corner, what we'll have to do is tell Azure AD about the issuer certificate, the intermediary certificate, and also the root CA certificate. So we'll actually have to add 3 certificates into Azure AD. We'll also have to tell Azure AD where it can find the certificate revocation list and also the Delta CRL. So we'll need to supply the HTTP public-facing URL to get to those 2 different lists. Now, in my example, it's very easy for me. All I've got to do is tell it about my root CA, because if you remember, I am actually issuing certificates directly from my root CA. So let's actually just go and do that. Let's get Azure AD trusting our certificates. So I'm working with the Entra portal. I go into Azure Active Directory, and then under Protect and Secure, I'm looking for the Security Center. I can't see it, so remember, you've got Show More down here. Click on there, and there's my Security Center. Now, I need to go to Certificate Authorities. And I've got 2 separate certificate authorities actually sitting in Azure AD or registered in Azure AD. And what Azure AD will do is trust certificates if issued by either or both of those authorities. If I want to add an additional authority, I simply click on Upload, and I need to put in the certificate for the CA root. I need to put the certificate in for intermediary and also issuing CAs. Everything in the actual certificate path I need to load up there. Okay, once I've done that, or as I'm doing that rather, I need to specify if the certificate I'm loading, is it a root certificate or is it an intermediary or an issuing CA certificate. I'll then supply HTTP URLs to where the certificate revocation list is stored. Obviously, it needs to be publicly available so that Azure can get to it, and also where the Delta certificate revocation list is stored. And that's it. I've now got Azure AD trusting my certificates. Okay, so we're nearly there. There's 3 more things we need to do. The first one is to target who can actually use certificate-based authentication. And to do that, we create a group of our users, and in the certificate-based authentication, we actually target to that group. So that becomes our target. So that's nice and easy. The next thing is, and I said this right at the beginning, is okay, so we have a certificate. How does it identify a particular user? So that requires mapping a field in the certificate to an attribute of the user. Well, the simplest way to do that is to use the principal name in the subject alternate field of the certificate and map the principal name to the user principal name for a particular user. Now, the problem with that is it's very easy. If someone actually manages to hack a certificate, they've very easily got that mapping and they know what the mapping is. Another way of doing it is to use a field called the certificate key identifier and actually map that to a particular attribute, and that's the cert users ID attribute. So we have here is the cert users ID, and that's an attribute. It belongs to the user, and what we'll have to do is that an administrator will have to take the SKI value and actually load that into the cert users ID for the particular user. And that takes care of our mapping. There are two forms of mapping, one of which is called a low affinity mapping, and that's where we just take the principal name and map it to a UPN. And then where we take the SKI and map it to an attribute of the user, which has also got the SKI value in there, that's known as a high affinity mapping. One last thing to do, and that is to take into account the fact that we can define the authentication strength of the certificate. We could say that all certificates are strong authentication, i.e. they can be used and treated as multi-factor. Or we could treat them as just first factor authentication. It's our choice, and we can do that by saying all certificates of this type or the other type, or we can say all certificates are single factor, except if they have a particular OID value set in the certificate policy. Let's have a look at this. Okay, we're into the last steps of our jigsaw puzzle. We need to go to authentication methods and we'll look at certificate-based authentication. And we can see that it's enabled and it's targeted to members of the cert auth group. If we look at configuration, we can see that the protection level is set to single-factor authentication, except for certificates that have a policy OID value of 1, 2, 3, 4. If they have that particular value as a policy OID, they're treated as multi-factor certificates, so they have multi-factor authentication strength. What I'm going to do is go across to our server and look at the CA again, and what I've got up here is CBA user set name. This is where I can set the name for the certificate on the certificate creation. If I look at the extensions on that and under issuance policies, there are no OIDs in there, so this is definitely not going to be treated as an MFA certificate. So I'm going to cancel that and that one, and then I'm going to look at this one, which is, again, we can set the user at the time of creation, but this is going to be strong. So we look under extensions, we see that it has MFA in there. If I double click it, we can see MFA represents an object identifier of 1.2.3.4. So that is going to meet our multi-factor authentication requirements. Okay, let's go back to our client. If we go into our certificate store again, and I'm going to go all tasks, request a new certificate. Once again, it's going to be from our Active Directory enrollment policy. And I'm going to take the CBA user strong set user certificate, and I'm going to put in here a subject name, and which is going to be a common name, and I'm just going to call it strong. Okay, I'm not even going to bother with setting a principal name. If you remember before, we set the user principal name, which did the mapping for us. So I'm not going to do that. I'm going to click OK on that, and I'm going to go for an enrollment and finish that off. And now we've got this certificate, which is MFA, it's smart card, and it's issued to strong. And if I look at the details, I've got down here, I actually have somewhere, where am I looking, a subject key identifier. Grab that, I've got that now in my clipboard buffer. So let's go back to the portal and let's look at our binding. At the moment, we've got our principal name is mapped to a user principal name. We've got an RF822 name mapped to a user principal name, and those are the bindings that we've got. But what I can do is I can use the subject key identifier, and I can map that to a specific attribute for a user. So it's the certificate user ID, and I'm going to save that. So I've now made that change, and what I'm going to do now is I'm going to go to my users, and I'm going to choose a user in here, so all users, and I'm going to choose my user Tina. So I'll just reorder this lot just to make life easier. There's Tina. And I'm going to come down here into her properties. And I'm looking for, or down here is the certificate user IDs. And now I'm going to add one, and I'm going to add the identifier in. Now, it has to be in a particular format, so I'm going to go into Notepad, and it needs to be in here. So I've just picked up, remember, I picked up the subject key identifier. I'm going to put that value in there. I'm going to grab all of this, and I'm going to pop it in here. And I'm now going to save that, and I'm going to save thing. So now we could get to Tina by mapping a user principal name, or we could use a certificate for Tina using this subject key identifier. So let's go back to our client and let's just close this slot off. So I'm going to go into OID CV1. I'm going to sign in. I'm going to sign in as Tina, but rather than using Tina's first factor, I'm going to go in and use this strong certificate, which is going to be mapped using the SKI. So it's a one-to-one mapping between this certificate and Tina. So okay, that, and we're in, and it's RSA and MFA. So that's showing the use of high affinity binding. Well, that's it. Get started with certificate-based authentication. I hope you found the session useful. It would be great if you could leave me some comments. Don't forget to subscribe and keep learning until I see you in the cloud again. Thanks for watching my channel. Subscribe for more free training. You might like to join me for my Identity Masterclass. Hopefully, see you soon.